Hello friends, myself Darpan Saluja. I am computer programmer. In this video, we will learn about the factoring of polynomial in Sympy package. In the last video, we have seen what are polynomials. Polynomials are basic algebraic expression having one or more terms. Solving the polynomial is simplification of many algebraic expressions and is useful tool in solving high degree equation, that is factoring. Now factoring's base is greatest common divisor, is the largest positive integer that divides each of the integer. For example, the GCD or greatest common divisor of 8 and 12 is 4. Greatest common divisor between two polynomials. Let's do it in Sympy package. First polynomial expr is equal to poly x double strike 2 minus 1 expr. Shift enter to run the code. It is x square minus 1, and second polynomial second polynomial expr1 is equal to x double strike 2 minus 3 into x plus 2 expr1. Shift enter, x square minus 3x plus 2. Now the GCD, greatest common divisor between two polynomial, is GCD of expr comma expr1. Shift enter, that is x minus 1. X minus 1 is that polynomial which is the greatest common divisor of both of these polynomials. Greatest common divisor between more than two polynomials. For that we will use the method GCD list. Let's try it in Sympy. Expression is equal to x cube minus 1 expression. Shift enter, it's x cube minus 1. Now define the second expression, that is expr1 is equal to x square minus 1. Shift enter, let's print it also, it's x square minus 1. Expression number 3 expr2 is equal to x double strike 2 minus 3 into x plus 2 expr2. Shift enter, x square minus 3x plus 2. Now the greatest common divisor, let's call the GCD method and pass the three polynomial expr1, expr2. Shift enter. Okay, object of type add has no length. Okay, we will have to pass it as a list. Okay. Shift enter. Now x minus 1 is the greatest common factor between three polynomials. Now what is basically factoring is number, for example number 8 has factor 2 into 4. Now x cube, if we can divide x cube minus 1, x square minus 1, x square minus 3, x plus 2 with x minus 1. This is the common greatest factor between the three polynomial. Now number 8 has factor 2 into 4. It can 2 into 2 into, but 4 is the largest factor. 25 x square minus 9 have factor 5x minus 3, 5x plus 3. Means factoring is simplification of algebraic expression and is useful tool in solving higher degree equations. So we are doing, we are converting to a higher degree equation to a simplification form. Factoring is finding what to multiply together to get an expression. Through factoring we rewrite our polynomials in simpler form. There are many type of factoring. Basically there are 6 type of factoring. Method for factoring polynomial, but in Sympy you don't need to learn about the 6 type of factoring. You have to just call the factor method provided by the Sympy package. Let's try it. Expression is equal to 8 into x 4 minus 4 into x double stack 3 plus 10 into x double stack 2 and expr dot factor shift enter. So what happened here? 2x square is the greatest common factor of this polynomial. 2x square into 4x square, 8x4 minus 4x cube plus 10x square. So 2x square is the greatest common factor. We are simplifying the polynomial into the lowest degree by calling factor method. Factor by grouping. This is our polynomial x cube minus 5x square plus 3x minus 15. First group, second group. In the first group, x square is the largest greatest common factor, GCD, and in the second is 3, and so the answer is x square plus cube and x minus 5. Do it in Sympy. X cube minus 5 double stack x square plus 3 into x minus 15 and print expr shift enter. Okay, where x cube minus 5x square plus 3x minus 15 and expr dot factor shift enter. I have done something wrong. X cube minus 5x square plus 3x minus 15 5x square. This is our polynomial and this is our factor. Factor of quadratic. What is quadratic polynomial? A polynomial having degree equal to 2 is quadratic polynomial. Method is the same. We have to call the factor function of the Sympy package. Expression is equal to x double square double stack 2 minus 20 into x plus 100 expression shift enter. It's x square minus 20x plus 100 expression dot factor shift enter and x minus 10 whole square. So this is the factoring of quadratic polynomial. Polynomial of type x square plus 2xy plus y square, simplify it into the form x square plus y square. It is the expanded form of right hand side and this is the simplification of the left hand side. You can say that expression is equal to x square plus 2 into x into y plus y square expr shift enter, insert cell above expr dot factor shift enter and x plus y square is our form. X plus y square we can write it x square plus y square. Take the result into expr1 is equal to this and expr1 shift enter, insert cell above. When you expand it, dot expand shift enter, it will expand into the right hand side, left hand side is expanded form, right hand side is simplification form. Polynomial of type x minus y square x square minus y square expr is equal to x square minus y square expr. Enter this expr dot factor, and the result is x minus y and x plus y. Factoring polynomial with degree greater than 2 method is same. We have to call the factor method. The process is same. We have to call the factor method. Expression is equal to, now the degree is 4 minus 25 expr dot factor, and the result is x square minus 5 x square plus 5. We are reducing this polynomial to the lowest degree form, or we are simplifying the polynomial by factoring. Now getting coefficients of polynomial. For getting coefficients of polynomial, suppose we have defined two symbols, x and a is equal to symbols x comma a, and then our expression is equal to 3 plus x plus x square plus a into x into 2, shift enter, let's print it, expr, shift enter, it's 2ax plus x square plus x plus 3. Now when you call the coefficient method, expression dot coef coefficient of x, it will return you 2a plus 1. Coefficient as dictionary, let's use it. Insert cell above, expression dot as coefficient underscore dictionary, and shift enter. As coefficients, coef coefficients, I have missed the I. So ax has coefficient 2, x square has coefficient 1, x has coefficient 1, 3 have no x. So the coefficient as dictionary returns us the coefficient of all the x's in terms of a dictionary. Coefficient returns a list containing all coefficients which has a value, and ignore those coefficient which is 0. Whereas all coefficient return all the coefficients including whose coefficients is 0. So here our coefficient is ax is 2, x square 1 and x 1. If we do it again, suppose our expression is 3x, this x square plus x 4, and we call then the method expression as coefficient degree, then the result will be x4 is equal to 1, x square is equal to 1, ax has coefficient 2 and 3 has no coefficient. So coefficient list returns us all the coefficients of a polynomial expression. For now it's bye and thanks for watching this video. In this video we have used the factoring of polynomial. We have done the process of factoring the polynomial using Sympy package or symbolic computing. Thanks.